My name's David Rowland. I'm currently the lead developer at Traction. I work mainly on the Traction DAW host, but also on our other software products, including our plugins and web integration, and manage those teams at the moment as well. So programming is tough. It's tough for many reasons, but one of them is the amount of things that you have to consider for almost every single line of code that you write. So you're probably familiar with all of these things, but we have to think about performance. One of the reasons a lot of us choose C++, readability, you might have coding styles to adhere to, maintainability, reusability, robustness, security, portability, compatibility, scalability, lots of abilities. One important thing to notice about some of these things is how many of them are actually in the future. If you're thinking about compatibility, scalability, reusability, maintainability, all of those things are unknown at the time you're writing your code, which is a tough problem to solve because it amplifies it. So what are the solutions to these problems? How can we make our lives easier? Well, one really simple solution is just to write less code. If we write less code, then physically there's less taps on the keyboard that we're writing. There's less time reading it for yourself and for future self or teammates. And there's less to reason about. If there's less to reason about, then it means we have to keep less in our head and we should be able to code easier. So C++ 11, although it's a few years old now, a lot of code bases are now just moving to it. We, with Traction, only managed to move to C++ 11 last year. It introduces a ton of new stuff that can help write us less code, including type deduction, the new threading libraries, lambdas, function objects, variadic templates, range-based for loops we'll look at a little bit, but mostly we're going to look at brace initializers today and the std initializer list. So specifically, new examples of brace initializers. We're going to look at constructor object deduction, object constructor deduction, aggregate initialization, and member declaration brace or equal initializers. This is a bit of a mouthful. The standard in their recent Kona meeting has proposed a paper 0134R0 to change this name to default member initializer, which is much better. But currently this wording is in the standard, so if you go away and look it up, that's what you'll see. So that's what we'll stick with today, even though I might get it wrong a few times. So our first example, most of these are going to be JUCE-based examples, largely pulled from things that we have in Traction. So first of all, when we're returning objects. This is a class similar to something we have in Traction, which is populating or getting a path to show in a list box for various plugin types. So we have kind of the standard VST, VST3 audio unit types, and then two of our own rack and internal types. So what's wrong with this code? Well, it's quite a mouthful, and it's a mouthful completely unnecessarily. The function's very small. We can see the return type very clearly in the top left. You can see that on probably any size monitor, including the projector. But we have to repeat the return type, std pair, pointer to path, float each time. Just a quick note, the reason we're returning a pointer to the path and float is that the float is a scale. Because different icons are kind of different weights, we use a scale so they look even. So how do we go about trying to change this? Well, with C++ 98, we could perhaps declare the path and the scale once and then assign to it in the switch case. But then we've got all sorts of other problems. We now have to have these break keywords in there. And if we try and add a new type and we don't put the break, then you'll get fall throughs and you get the wrong type. And we've just made it more difficult to copy and paste. Basically, don't do this. What you can do with C++ 11 is just completely omit the return type. Notice we have braces here instead of brackets, which means these are just the arguments that are going to be passed to the std pair constructor when we return. Now, because there's less code here, it's a lot easier to see what we're doing. You can very quickly look at this, say, right, we've got a function, we've got a switch case, and we're returning a pair of arguments from it. The other thing we can do is, instead of returning the default null pointer 0, is we can just return a set of empty braces. This means construct a default object. Now, I really like this. It's useful for many reasons. One is if you've got a lot of functions like this and you're returning a type of object, usually you have some kind of default at the end. We had a load of classes that return in JUCE images, a load of functions that return in JUCE images. Then we changed them to return pointers to drawables because some of them were scalar graphics and we wanted them to show on high DPI displays correctly. And just using this syntax means that you don't have to change all the return types. There's no kind of image, empty brackets, or null pointers anymore. It's also a lot easier to see the intent, I think. If you've got this pair of empty braces, you can immediately spot, oh, this is a default object. If you've got some complex control flow and you're maybe returning several times in that function, then having this pair of empty braces is immediately obvious what you're doing. You don't have the null pointer 0 everywhere. It's also worth noting that this is probably more easily optimizable than using static members such as string empty, value tree invalid, there's var null, and any number of them. Because the compiler knows this is just a default object, it doesn't have to do any kind of lookup to actually get the object you're referring to. Which means in some cases, if the branch predictor can figure out that we're never going to call any of these, it might even just avoid calling the function completely. So on to our second example, which is kind of similar to the first, is when we're constructing objects, passing them to things. So this is a very simple paint routine. We're essentially getting a square wave path this left from a library function, and we're adding a line through it to show that this square wave has a positive and negative range. So the lines we're interested in are these yellow lines here. And if we move on to the next slide, we'll see them again. Essentially, the only meaningful bit of code here is this last white line. There's a few problems with declaring lots of variables like this. Say we had more drawing code underneath this line, then we were using points to define it, then we'd have to start at P3 and P4 or L2, which is a strange place to start if you're defining something. So the scope is a bit of a problem. We've also got point float declared twice, the lines declared. None of this really matters to what we're doing. All we're really interested in is the 4 numbers to the right of the points. So how can we improve upon this? Well, C+98, we could, instead of declaring the points, we could just specify the line using the coordinates. But then we've got slight ambiguity. How do you define a line? It may be obvious if you know what the line class is, how it's defined, but there are several ways to define a line using 4 arguments. And there might be default arguments that we can't actually see there. So again, there's more stuff that we have to reason about, you have to think about. You might have to go to the docs to look it up. So how do we disambiguate that? Well, again, we could write it all in line. We could have the add line segment, but then we're declaring the line and then the 2 points to it. It's fairly explicit what we're doing here, but you can see how long it is, and it takes a long time to read. So with C++11, we can just omit the types. If we use braces instead of brackets, everything will compile nicely. All the types will be automatically deduced for us. So this is less typing again. It's less time to read. It's also good because if you wanted a double precision line instead of a single floating point line, you could just remove all the Fs, everything would just compile again. But probably the most important thing with using this syntax is that it's incredibly clear what we mean when we define a line now. We've got two sets of arguments here. Now, ever since GCSE, and maybe even before that, we've been writing x, y coordinates in a pair of brackets. We've been going x, comma, y. Now, if anyone reads this and they've done any kind of maths, then they should probably realize, okay, this is a pair of x, y coordinates. It's closer to how we think about things in the real world. Similarly to the last example, we're kind of augmenting a predefined shape here. To show that you can click on this to have some various drop-downs. But instead of the 4 arguments that we had before, now we've got 6. Now this is a real pain, and I don't know how many of you have tried to change small triangles and get them to move by a tiny pixels amount, but I'm always changing the wrong coordinate, hit build, wait for it to compile, run it, and then you change the wrong one. So again, to more easily show our intent with this, we can use the brace notation. And now it's very clear that we've got 3 x, y coordinates. And you can obviously see all the x coordinates because they're just on the left-hand side near the braces, and the y coordinates are on the right-hand side near the braces. So this is going to save you time when you have to go and edit this. So third example, using initializer lists to reduce the use of temporary arrays. This is a really verbose bit of code. You don't write code like this, but essentially what we're doing is, in Traction we have something called a step sequence clip, which is a series of channels based on a MIDI note number, and then you have a grid that you can kind of toggle notes on and off. So if you create an empty one, it will go, oh, you probably don't want an empty one, we'll give you some default MIDI note numbers. So these 35, 38 are the MIDI note numbers for kick, hat, snare, those kind of things. So what we're essentially doing is iterating over this array and then calling the add channel function to populate our clip. So what you're more likely to do is write something like this using a C-style array with the numbers in, and then use a for loop to iterate over that array. You'll probably use something like the num_elements_array macro that's provided in JUCE, but there's other ones as well. And then you'll dereference that array and pass the number into it. So there's still quite a lot of boilerplate here. You see all the yellow stuff is really just syntax noise that we're not really interested in. The other thing that you can see here is notes is kind of on the stack. It's still in scope for anything underneath, which means when you're writing code or changing this, you have to keep in mind what's the effect on any following code as I'm changing this. Just keep that in mind as we progress through the example. So in C++98, we might not just be calling using the number once, we may be using it twice. In this example, we're also providing a name for the channel, which is going to be displayed on the screen. So we've ended up dereferencing this array twice. We've got this extra repeated notes dereference here. So how do we improve this in C++11? Well, the first step we can do is, instead of using a C-style array, is we can use a std initializer list. I almost always use auto with initializer list because it's very clear that this is an initializer list. It also means if you change the arguments, then you don't have to change the type, and I don't really like this underscore syntax, so auto gets rid of that. Used in conjunction with a range-based for loop, almost all the bloat just disappears now. We can easily iterate over the notes array. We have a single variable n that we're using, and then we can just use that n twice when we pass it into our add channel function. But we don't even need the notes variable. We can just declare the initializer list inline in the range-based for loop. Now, we haven't got this scoping problem that we started off with. The only thing you have to reason about for these two lines of code is these two lines of code. We've got a for loop, we've got a variable n, which is going to represent each of these numbers. We're calling a function, and we're passing the two arguments there. There's very little I think you could do to reduce the amount of code here. Possibly you could get rid of the auto keyword, and if you just had a variable name, then you could auto it. But essentially, that's very, very minimal. And because it's so minimal, it's very clear what you're doing. There's no bloat that you have to read and go, oh, what's that? What does this mean? Where's this going to affect something else? So onto our fourth example, we're going to look at member declaration based on equal initializers. So again, this is another class similar to something we have in Traction. It's a bit stripped down, but it's a MIDI note. That's a concrete kind of class that's used to represent a MIDI note in a sequence somewhere. We have various properties. We have the start beat. We've got length in beats. We've got a note number, channel, and a velocity. We also have a color index because the note might be colored differently. And we have this note ID member as well. Note ID is important because it uniquely identifies a note in a sequence. Because you might have looped sequences, the sequence that's displayed to the user, as you drag notes around, you still want to update the original sequence, which is unlooped. So it kind of uniquely ties these things together. This is always a unique number. Get next note ID just returns an incrementing integer. One of the things we did with Traction 6 is we rewrote our entire edit model to use JUCE value trees, which was awesome. It's so much better now. So one of the things we had to do was add a value tree constructor, which just looks at the properties of the value tree and then initializes all the members. But who can spot the bug that we've introduced by adding this constructor? No note ID? No note ID, yes. So what does not initializing note ID mean? It's a horrible, horrible bug, this one. And it's horrible because it means note ID is actually initialized to junk. Now, because note ID is supposed to be a unique identifier, in a lot of cases, it will be initialized to something unique, especially in your test cases where you've got 8 notes and you're going, right, it's fine, yeah, they've all got some junk value, and out of the many thousands that they could be, it's probably going to be unique. So what happens? Ship it. You get your composer sitting in a studio in LA somewhere who's got tens of thousands of MIDI notes. They're editing a first bit of their sequence, they're moving some notes around, but unluckily, the note ID for one of those is also the note ID for a note at the end of the sequence. So they're happily playing away, they probably won't even notice this, then they'll come back 3 days later, play the end of their sequence, and it'll just sound like rubbish. So they go, oh, there's a bug, something's happened with my notes. You'll get it back, you'll open your test case, 8 notes, nope, no bug, ship it again. It'll go on that for a long time. Basically, it's hard to track down, so we don't want this bug. So how do we fix it? Well, we obviously initialize it with get note ID like we have everywhere else. So what's bad about this? There's a lot of repeated code. We've initialized color index to 0 3 times, note ID to get next note ID 3 times, and we kind of just repeated for the default constructor all the arguments. They're all just zeros. That seems like a bit of a waste. So with C++11, we can use brace initializers to initialize the members where we declare them. You can use an equal sign here. There's debates on the style. I know Jules prefers the equals because it looks less like a function call. I prefer the braces because it looks more like a constructor initializer. Okay. And also you get narrowing errors if you use the braces, but that's one for the pub afterwards, I think. Other important things to note, you can call functions in initializers here. So we're calling get next note ID, which means if we add another constructor, note ID will always be initialized to something sensible here. We've made it impossible to introduce our previous bug. Other cool things, the default constructor disappeared. Pretty much non-existent now. We just have it there to specify that there is one. The other thing to note is that constructor initializers, so these here, will take precedence over brace or equal initializers. So if you've initialized note ID in a copy constructor, for example, where you're taking the note ID from another note, then there is no function call. There's no overhead to this if you've actually initialized something. So if we look at our C++98 version and our 11 version, we can see the size is reduced by about 25%, but this is a trivialized example. In production code, we have many more constructors for MIDI note. You're likely to see better gains. But most importantly, it's now easier to see the intent of the class. It's more compact. You can just look at the constructors and say, right, here's one that takes a note, sort of various parameters, and here's one that takes a value tree. So it's just quicker to read. There's less to keep in your head when you're looking at the code. We've also shown that it's more robust. The note ID bug is all but impossible to introduce now, and it's more maintainable. If you add a constructor that takes, say, one argument, you know that you don't have to repeat these huge initializer lists of just zeroing everything out, basically. And this is a fairly trivial example. You'll get classes with much more member variables than this. So in summary, we've used C++11 brace initializers in 3 ways. We've used object constructor deduction, we've looked at aggregate initialization and std initializer list, and we looked at member declaration brace or equal initializers. And it means we've written less code. Less code, as I mentioned, means it's quicker to write, less typing, less tapping on the keyboard. It's quicker to read for yourself and for other people, which means there's less to reason about, which is simpler because there's less to keep in your head. There's less to think about. You can focus on the engineering problems that we all love. It's more expressive. The intent is clearer. It kind of flows more how we would say something in English. There's not all this horrible syntax that we wouldn't inject into something if we were explaining the problem to someone. We've also made it more robust and maintainable, and it's also more likely to be optimizable. Optimizers work best when you give them the most freedom. They like to do things with your code. If you kind of inject lots of explicit statements in places, then you're restraining the amount they can do. Using this kind of style means you basically give them freedom to do the best job that they can. That's it. Thanks very much for listening.